today's just been a hectic day for developments. I can't keep pace with it. Now, mashallah, we've got Steve, we've got Jake, and we've got Wayne, and I'll just let's listen to it.
I thought it was actually a good comment. So, guys, what we're looking at today, what you see here, and this is Friday, September 23rd. I'm sitting here with Wayne Steiger and Jake Riley. The two people that help me to analyze events that are going on. We are looking at and just looked at a couple of pieces of footage that show what NASA and SETI being the naval observatory and where you can get a lot of images from space, different satellites, showing us what they say is Mercury, and it looks like it's diving into the sun. And so my friend here, Jake, sends me a note to go look at this video. And in fact, I will show you this video again so that we can do this comparison. And I have a good cutoff point to restart the video. Wayne Steiger is sitting over there eating chocolate bonbons or some damn thing.
Chocolate almonds, man. I mean, gourmet.
All right. Okay.
That's all I gotta say.
It's cool. It's cool, baby.
Hey. Chocolate is the number one food group. I'm just telling you.
So we're watching what they labeled as Mercury dive into the sun and then not come out on the other side. I think that's the point of that little video, right?
Yes.
And then you come back over here and show us this video here, which shows the last time it made its pass back in May. And again, we don't know for sure if this is Mercury or not. The last time I saw this object, which by the way was back in May, I actually did a video about it, and I was questioning if it was Mercury or not, because when it came in on Core 2, it looked really, really bizarre, and that's what I'm going to show you guys here for a second. So, Jake, did I make your point? This is a different orbit from what we saw in May from the same device, right?
Yes, that's exactly correct.
All right, so here's my study from today. And basically what I did was I went and pulled SETI Core 2 and similarly did a view from there and did a kind of a simulated time lapse by just doing, cutting 1 hour frames to watch this thing come in from the right, okay? From the left.
All right. From
this satellite's view. So it kind of goes slow. So let's see, I can speed this up actually. Just give me a second here. The modern technology is awesome. Here we go. So now, here's your object coming in on Core 2. I pulled the Earth scale over because I said, wait a second, Earth is just a tiny dot compared to this bad boy. Just so people can see. There's Earth.
Yeah.
And then it freezes, and I lose images at a certain point here. I don't know how far I can go here. I think it was the 20th at some point in time I could go. But watch as it dives into the sun. Wayne, stop, Wayne. Wayne?
Yes.
What does that look like to you, man?
Jeez. Well, you think it's our shield friend?
No, see, it's got that plasma effect that Jeff P was talking to us about.
Yeah.
Like a plasma charge where two forces. I forgot what exactly the terminology you used for it, but as I try to blow this up to the maximum size here, guys, does that look like Mercury, man?
No.
Wayne, I'm stupid, okay, in many ways. That's why I like you on the show, because you're smart.
Yeah. Obviously, you haven't been to Vegas, have you?
No.
Look at that. What happened to there? Did it? Okay, so it went behind the oculator, right?
Correct.
Okay.
So now I'll just kind of pull it back out a little bit so we can see the bigger picture here.
The oculate is the disk, and then the sun will be maybe about the size of that, where that circular red, the X, but in the center of the oculate.
Again. And then I think it freezes here in a few more frames, but it did not come out the other side of this one. And so this is, oh yeah, this is fun.
Subhanallah. Now, if you look at the size of those CMEs and then look at the size of Earth, Earth is literally a dot. It'd be smaller than the point on that cursor. The actual, apex of that cursor and that point, it'd be smaller than that in that black box. And if you look at the CME that's come out, and then you look at the magnetic field video that I did today, which explains that, right? That there's been a coronal mass ejection coming out of the sun, and that's hit our atmosphere and pushed our magnetic field back, right? And this is why we're seeing some extreme weather. Chances are, in the next 48 hours, we're going to see a lot of extreme weather, as well as earthquakes and volcanic eruptions again. There seems to be a huge connection between the two, as and when it occurs.
Wow.
I love it when they do that.
Yeah.
What's going on here? By the way, this little dot right here does not move.
Well, it should. I mean, the field behind the sun, I mean, it should be in a constant...
There's just too many anomalies now that we can't explain. That's not been seen since we've been studying, as in it's been documented with technology our solar system has. I mean, these are satellite dishes that pick up footage in the infrared spectrum, as well as photon light emission, and they interpret that into visual footage. It would never been picked up. So all these anomalies that are occurring right now are indicative of some alien system that's entered our solar system. They can't be explained in any other way because we're unable to recognize them. None of them have the signature of the celestial bodies that orbit our sun. None of them.
Motion.
So anyway, just to kind of go back, just to and just kind of there's the object coming in. Now, Wayne, this next image that I'm going to show you might shock you a little bit. I'm just putting what I found today.
Hey, Steve. Yep. Does that look like that's actually coming up from the ecliptic plane? Or is that just an illusion of the camera?
It's got to be an illusion of the camera. I don't talk about relative to the ecliptic plane anymore, because if it's not like almost straight up and down, it gets, it's hard to say, right?
Yeah, it's true. It's, well, when you're in space, what is up and down?
Right, exactly my point. All right, so this other image, now check this out. Now, this is interesting because, Wayne, you are going to recognize this from what you're going to show us in a minute. And this is new to you. This is from Germany.
Look at that. Oops. Now, I hadn't seen that, Steve. I did not see that.
Nope, these are new images that I have just been working on for tonight's show. And this is one. Oh, come on now. Don't mess with me here. All right, so this is from, one of the German, cameras, okay? And look what we got up there.
Now, that's odd.
It moves, by the way.
Wow.
Okay.
Seems awfully close.
Yeah, well, you have a corroborating set of images from 2020.
We made certain claims not so long ago when we said that when we see that comet with the two tails in our atmosphere, and I've discussed this with my friend at over a meal in an Afghani restaurant, where we mentioned that when this comet is seen again in our horizon, then expect this system to be much closer and on its trajectory out of our system back to its elliptical orbit, and now we're seeing all these anomalies which are probably grouped together with this system. And as it's going out, it's becoming clearer and clearer and more visible. And this is why we're picking up all these strange things in our sky that just don't belong there.
Well, that you just showed us that you're gonna help us with. I hope tonight.
I keep on telling you, gentlemen, I'm becoming more and more, favorable to the theory that this system, it may be much larger and it may be a much more constant variable in our solar system is what I'm trying to say, because it just, I don't know. Let's see what we got.
Right. So again, so here's another set of images that I did. Same thing, looking at it coming in. From core 2 this time. Same deal, okay? And the reason I want to show you guys this is, and kind of focus on this, is I have a feeling that, and again, I'm going to take a little bit of a chance on saying this, but the stuff that we're getting from Dave Dobbs and from the Nibiru channel, and I'll show you what I'm talking about here. I'm sorry, I just have to get to my previewer here. This is from, he has decided to corroborate with us. And so he sent me some hot pictures. Here's the first one that shows this kind of object. And again, this is what I saw with my own naked eye to the left of the sun as I was driving into the sun on Tuesday from Memphis, Tennessee, for that area.
Interesting. We just mentioned this comet with the two tails, and Dave Dobbs did a very good. We talked about it. There's a previous upload. I'm sure you'll recollect it. Where we discuss it's got this 200-day, almost a 200-day orbit around the Proton star, and we should be seeing it maybe in October, I think, but we've actually seen it much more earlier. So there's something strange happening to the pattern of its orbit. But what I did mention is when we see it next, it's very likely that it's on its trajectory out.
These are also pictures from the 17th of September of what Dave Dobbs has been calling some Nibiru. He calls it Nibiru, and he thinks this is the comet that flies around.
I certainly don't think it is. I think it's a comet with a lot of debris in its tail, as well as it's ejecting plasma whilst it's moving really fast. It's been mistaken as a planet. I think this is at least my position on this from the research I've been doing. It certainly can be wrong. There's that's very possible. But still, I mean, my feelings are that it's not certainly not Nibiru or any planet as such.
Nemesis, but they are calling this. Now, check this out, guys. They are calling this the asteroid.
Really?
Yeah, and I don't think it's an asteroid. Okay, just don't.
Wow.
Right. And so you remember we saw those pictures from Tennessee, right? That showed the same thing over left to the sun just the other day. So I am suspecting that this and what Jake has helped us to see here, Wayne, with this object may be the same object. That's my theory here.
Well, do we have any way to see what? Go ahead, Jake.
That doesn't seem as far fetched. Look at the shape of Mercury supposedly here, and I pointed this out when I first made a video about this a couple days ago. The shapes didn't seem It's clearly got wings. There's a tail on it.
This is the spot right here. To your point, Jake. See how it's got this streak coming off of it?
Yep.
Does Mercury have a streak coming off of it, Wayne, or am I?
Not the last time.
I could be wrong. You know, I'm wrong a lot.
Isn't that a plasma reaction coming in behind the planet?
Possibly.
And that flash frame you showed?
I believe it could have been, yes. But then look, when it gets close to the sun, it just stops all activity, and then it bifurcates somewhat, and then dives into the sun. It's just another one I did today.
Wow. Yeah, like I was saying earlier, if you took the footage from the 15th and rated 88 days, it should have happened again on August 11th, but we're only catching this on September 20th, so.
What does that mean?
What I'm saying is that today we're watching this go across the sun. All right, and I just subtracted 88 days to see the last footage, but that I had to go back further than 88 days. So what I'm saying is it took longer. If this is Mercury from May 15th till now, it took longer than 88 days to do the same thing it did today.
You see, that's interesting. I mean, the point that's being made over here, and now he's referring to Mercury, is that the orbit of Mercury has changed as well. It's taking longer for Mercury to orbit, so something's disturbing its orbital trajectory and its speed. And again, we've kind of noticed the same sort of pattern with this comet, which was circular for around about, I think, what was it, 200 days, but now it's been like getting shorter and shorter and shorter. What they're saying over here is potentially it was that comet that was seen in the skies with the two tails that potentially was what basically dived into the sun. But again, I mean, the point over here is that the patterns of orbit and the times are being changed, and that would happen if there were other influences within our solar system.
So then I wanted to see if I could find it on Core 1, right? But instead what I find, guys, is this orb sitting next to the sun. And it scared me a little, and I just wanted to kind of get it out there to you.
Well, you know what they'll say. That's just merely an aberration of the camera. Nothing to see.
Here comes Mercury, I think. This is what I think was what they were saying was Mercury, or what we think is Mercury. But here, look at the Earth scale here. Something's wrong. Something's horribly wrong. But anyway.
Mercury in relation to Earth, smaller. So whatever that is, that's bigger. And that shouldn't be to the right of us. Right?
You can see this thing is kind of interesting here, isn't it? So I just took the Earth thing out of the way now so we could focus on where this ends up. So this is as close, like this is close into the sun, Jake, you know, as you know.
Okay.
So it looks like whatever this is might make it out of the corona, but the other thing that bothers me about these images is the big black spots on two sides and big, huge white spots on two. You know what I mean? It seems like the sun should have more uniformity when it comes to that stuff. I don't know, it's just me.
Can we go back and see from either SDO or which on the satellites out there? So it's an 88-day orbit. Now, if there's a perturbation to the orbit of Mercury that would make it longer than 88 days, then my next question is it reaching perigee or apogee in its orbit? Because we don't understand the perspective of where Mercury is to the sun in relation to distance. We can only see because it's basically being occluded as it's coming in. And the question I have is the passage in front of the sun, or is it going behind the sun? And can we confirm the last 88-day rotation.
That's exactly what I think Jake was trying to tell us, was that he did that, and he had to go back further than 88 days to see the Mercury orbit pass in front of the Sun.
There you go. So basically, we're confirming the same thing, that Mercury's orbit is taking longer than 88 days. So something is perturbing its orbit timescales, and that's got to be something quite substantial, because Mercury's always orbit the Sun in 88 days, in as much as we orbit our Sun in 360 days. That's basically Mercury's orbit. Now it's taking longer, so what's doing that? SubhanAllah, it's certainly not the pollution on Earth or carbon dioxide pollution, burning fossil fuels, that's causing that sort of perturbation for the astute of you who are listening to me right now, to Mercury's orbit. So again, there has to be some sort of influence which has a gravitational attraction towards these other celestial bodies within our solar system that's causing these anomalies. They need explaining. What is it?
Lights in this picture here.
So I'll write this down. So Jake, you actually now figure what you're the last that you were able to confirm was how many days?
Somewhere between 125 and 130.
Wow. Wow.
And see how much lower this is back in May, Wayne, here, where Mercury just seems to go right under the Sun, and you're just like, oh, there it is, that's Mercury. And Jesse from BP Earthwatch, he reamed me out because I said, I don't think it's Mercury. And he's like, that's Mercury. And I was like, I don't think so, and I just shut up about it, like a spoiled child. But anyway, then we come to today's version of this thing, and wow, I mean, you know what I'm saying, guys? This is a mystery. It's a mystery. I'm not sure it's Mercury. I don't know what to think.